Please, Charlie.
Good morning, students. My name is Prashant Jain and I will be taking lecture on number systems today. Let's start. Number system. If I really ask you a very small question over here, that which is the, in chemistry sometimes we ask this question, that which is the most fundamental unit that can take part in a chemical reaction? And the obvious answer is atoms. Atom is the most fundamental unit that can take part in a chemical reaction. Similarly, if a similar question is asked in the mathematics, that which is the smallest particle or the smallest unit which can take part in a mathematical reaction? Mathematical reaction means calculation. Chemical reactions, two reactants are getting added to give a product. Similarly, in mathematics, 2 or 3 or 4 or many or more than that units are added, multiplied or divided or subtracted to get the answer. So I am just asking you, which is that most fundamental unit that can take part in a mathematical calculation? Obvious answer is number. Then someone says integers, someone says rational numbers, someone says whole numbers. Then I am saying what are these different types of units are there? They are called numbers. So, and there should be some classification which defines these various types of numbers like integers, like natural numbers, whole numbers, rational numbers, irrational numbers, real numbers, imaginary numbers and so on. So that classification, we call that classification as number system. Let me throw some light on number system. Let's see. Suppose this is, I am saying number system. Then I will give the classification over here. There are two types of numbers basically in the whole of mathematics. This is imaginary numbers and this is real numbers. This term imaginary numbers. Imaginary numbers must be new to you. There is a separate branch of mathematics which deals with this particular type of numbers which are known as imaginary numbers. It is known as complex numbers. What basically what is the meaning of this imaginary number? If we do the square of a number, suppose the square of 2, the answer is 4. If I say what is the square of minus 2, the answer is again 4. Means whenever we do a square of a number, the answer is always positive. If I say that there are some numbers, if we do the square of those numbers, or if we raise to the power 4 of those numbers, we get the answer as, or if we do the square of those numbers, we get the answer as negative. For example, the square of root of minus 1. Root of minus 1. If I do the square of this thing, I will get the answer as minus 1, not as plus 1. So, such numbers whose square give a negative number are known as imaginary numbers. So, the most fundamental unit of these imaginary numbers is represented by small I, which is equal to root of minus 1. This root of minus 1 is allotted a symbol, assigned a symbol, small I. Small I represents a term called iota. Iota, it's a Greek word. Iota is a Greek word. So this is the most fundamental unit of this branch of mathematics of imaginary numbers, and the name of this branch is known as complex numbers. In class 11th we study these complex numbers. It is only an introduction I have given you over here. Rest, the detailing we will study in class 11. The only thing is that if you square a number, the answer is negative. And the most fundamental unit of this complex numbers is root of minus 1, that is iota, that is small I. Okay? Now let's come to real numbers. This is very familiar term. We are very familiar with this term real numbers. Let's see how. We know real numbers are categorized into two classifications. One is irrational numbers. Irrational numbers, okay, and the other is rational numbers, okay. We define real numbers as a group of rational and irrational numbers is known as real numbers. Now let's see. Irrational numbers, how do we define irrational numbers? They are non-terminating. They are non-terminating and non-repeating decimals. For example, square root of 2, square root of 3, square root of 5, square root of 7, square root of 6, square root of 10 and so on, cube root of 2, fifth root of 25 and so on. Okay? If you find the square root of 2 by long division method, the approximate value is 1.414, but actually it doesn't terminate over here at 4. It keeps on going endlessly, and there is no particular fashion of means decimals, digits after decimals. So it is non-terminating and non-repeating decimal. So it is irrational number. So these are examples of irrational numbers. The other is rational numbers. How do we define rational numbers? We say that they can be expressed in the form of p by q, where q is not equal to 0, and p and q are co-primes. It is defined in this way in standard form. Okay? They can be represented in the form of p by q, where q is not equal to 0 and p and q are co-primes. Now here comes a question: what are co-primes? Co-primes means does it mean prime numbers? No. Let's see. Prime numbers are 2, 3, 5, 7, 11 and so on. Okay? I am saying p by q. Does it mean 2 by 3? Does it mean 2 by 5, 2 by 7 or 3 by 5? Always. Means 2 by 3 is also co-prime, 3 by 5 is also co-prime, 5 by 7 is also co-prime. But the exact meaning is that p and q are relatively prime. That is, p and q do not have any common factor between them. For example, 15 upon 40. 15 is not a prime number. The factors of 15 are 1, 3, 5 and 15 itself. The factors of 14 are 1, 2, 7 and 14. 1, 2, 7 and 14. So, those numbers whose factors are more than 1 and the number itself. So they are known as composite numbers. They are not prime numbers. So 15 has factors other than 1 and 15 also. They are 3 and 5. Similarly, 14 has factors other than 1 and 14 also. They are 2 and 7. So both of them are not prime numbers. But you can see that 1, 3, 5, 15, 1, 2, 7, 14. These two sets do not have anything in common. So they are co-primes. They are relatively primes. So it is a rational number, p by q. P by q means that those numbers which can be represented in the form of p by q, where p and q are co-primes and q is not equal to 0, they are known as rational numbers. Now a question arises over here. If I say 16 upon 14, is it not a rational number? If it is not a rational number, that means it's an irrational number or it's an imaginary number. But it is not an irrational number. It is not an imaginary number. It is also a rational number. But this rational number is not in its purest form. It is not in its simplest or purest form, because there are still some common factors between them. If we cancel the common factors, this is 2 8 is 16 and 2 7 is 14. Now this is in its purest form. 8 by 7 is in its purest form. So this is, both of them are rational numbers, but that was not in its purest form. This is in its purest form. Now let us see the categorization of rational numbers further. Let's see. If I say, I am saying p by q. Q can be 1, q cannot be 1 and q can be 1. If q is equal to 1, then there is a type. If q is not equal to 1, then there is a type. If q is not equal to 1, then there are further classification. One is terminating decimal and the other is non-terminating but recurring decimal. Let's come here. What do we mean by terminating decimal? Terminating decimal means when we divide them, at some point they will come to an end. The remainder will become 0. For example, 1 by 2, 4 by 5, 6 by 5, 3 by 10 and so on. Okay? You can see that in this type of numbers, in the denominator, we will be having either 2 or 5 or both or their higher numbers or their higher powers and nothing else. The hint for these numbers is hint. In denominator, we have either 2 or 5 or both or their higher powers. For example, we can say 4 upon 25 or 6 upon 5 square into 2. they will be all terminating decimals. Non-terminating but recurring means 1 by 3, 1 by 6, 4 by 7, 6 by 11 and so on. Means if you divide them, for example 1 by 3 if you divide, you will get 0.3333. You will get 1 by 3 is equal to and so on. 0.30, 3 will keep repeating itself infinitely. So it is a non-terminating but recurring decimal. The digit 3 is repeating itself infinitely. So it's a rational number but it comes in non-terminating but recurring decimal. Now let's come here. Q is equal to 1 category. Q is equal to 1. Here we have integers, we have whole numbers and we have natural numbers. Here denominator is 1. Integers means -3, -2, -1, 0, 1, 2 and so on. Here whole numbers means 0, 1, 2 and so on. Natural numbers means 1, 2, 3 and so on. Okay, counting numbers are known as natural numbers. And then there was another set defined which includes 0 also. It became a new set 0, 1, 2, 3 and so on. 0 and counting numbers, they become whole numbers. And there is another set in which negative numbers are also there. -3, -2, -1, 0, 1, 2, 3 and so on. They are integers. So this is the classification of numbers which is known as number system, and this is how we began with mathematics. Means this is how the maths was started. This is the most fundamental unit which deals with mathematics. I hope everything is clear to you. Okay, in the next class we will continue further with this thing. Okay, thank you very much.